All right, number 111 here is a throwback to geometry. It's a distance formula question. It says find x such that the distance between 3 and -5 and x and 7 is 13. All right, so before we do the algebra, let's sketch a little picture and see if this makes sense. So here's my x and y axis. All right, I'm going to plot the point 3, comma, -5 right here. Okay. And we want to find its distance to the point x, comma, 7. So 1, 2, 3, 4, 5, 6, 7. All right, the line y equals 7 looks like this. All right, that represents every point that has a y coordinate of 7. And if we were to go up from -5 to 7, that would be 12. And if we go up one more, this length right here would be 13. All right, so I drew a green line where the length is 13. And now if I draw a circle centered at that point 3, comma, -5, we're going to, this green circle-y thing, I know it's not a perfect circle, but this green circle is going to represent every point that's 13 units away from the point 3, comma, -5. So you got one point around here, and another point over here. So graphically, we could see that we're going to get two solutions. All right. Now, at this point, once you recognize this is like a circle equation problem, you could do it a lot of different ways. But you don't have to use a circle equation. I would just use the distance formula. And the distance formula says that d, the distance between 2 points, is equal to the square root of the difference of the x coordinates squared plus the difference in the y coordinates squared. So d would be 13 in this case. All right, we can make x1 and y1 the point that we know, 3 and -5. And then the other point would be the unknown point, x, comma, 7. So we could do x for x2 and 7 for y2. So now we're solving this equation here, and it's a radical equation. This is why it comes up in this section. All right, to solve a radical equation, we want to isolate the radical expression, which is right here, and then square both sides. So we get 169 is equal to 3 minus x quantity squared plus -12 squared, which is 144, positive 144. All right, now I'm not going to expand this out because I don't have to. Don't expand anything out until you have to, because watch what happens if I leave it factored. All right, now I'm going to isolate that expression, 3 minus x squared, by subtracting 144 on both sides. And I get 25 is equal to 3 minus x squared. And now I'm going to get x alone by taking the square root of both sides. And this is where my two answers come into play. All right, the square root of 25 is going to be positive or -5. All right, because if I square 5, I get 25. If I square -5, I get 25. All right, then that equals 3 minus x. Okay, so now I'm going to break this up into two equations. Okay, 5 is equal to 3 minus x, or -5 is equal to 3 minus x. Okay, subtract 3 on both sides, and I get 2 is equal to -x, or x is equal to -2. There's one solution. Okay, so that would be like, I didn't draw it great, but it'd be like right around here. -2, comma 7 is 1 point. Okay, the other point would be subtract 3, and I divide by negative, and I get x is equal to 8. So my other point would be here at 8, comma 7. All right, oops, I didn't realize I was zoomed out there. Couldn't see that part, but there you go. Okay, so all I did was I took these two equations and solved them. And you could also use the calculator there and just have the calculator solve this equation. All right, if you typed in the calculator, solve this, comma x, it would find both these answers for you.